Now that we know how to make some basic quantitative data distribution graphs, namely the histogram and the dot plot, we want to talk about the potential shapes they can take on. Now, it's important to note that what we're about to discuss here is only true for quantitative data. It cannot work for qualitative data. That's because quantitative data moves inherently on the x-axis from left to right. And because it has that inherent quality, therefore we can talk about the shape. Qualitative data doesn't have that. You can put them things in alphabetical order, but that's not the same thing. And so the shapes we're about to look at will only work for numbers on the x-axis. Now, there are lots of potential shapes, but we're only interested in a few different types. So one type we want to think about is uniform. That's where roughly all the frequencies are about the same. So the data set is pretty evenly spread out. Now, you'll notice that this is a symmetric graph, meaning if I folded up my paper along this line, the left half and the right half would be pretty similar. Right? There are lots of symmetric graphs out there. Uniform is just one type of them. Another type, and probably the most important for our course because we're a parametric statistics course, is a bell-shaped graph. That's where we have the highest frequencies in the middle and it tails off on the left and the right. It won't be perfect, but you can see it has this kind of bell shape to it where it forms a bell, like that. Also symmetric. Also, if you could line up, divide the paper along the middle line, roughly the left and the right halves are roughly on top of each other, right? So these are two symmetric graphs that are also bell-shaped. Now, what about if they're not symmetric? Well, there's two particular types that we are interested in. We are interested in skewed right, also known as positively skewed, because this is the positive side of the x-axis and this is heading towards the negative side, right? Left and right. And it's important to note that the skew goes with a few. You don't think of the skew as where the clump is. You think of the skew as where the tail is. The tail is to the right. And because it has this tail off, this is skewed right or skewed positively, right there. And then there's also skewed left, right? So this has a tail to the left. And so these are skewed left. And again, think of where the tail is, right? The skew goes with a few. So it's this way. You might think, oh, what about this too? Yeah, but this isn't balancing out. These few right here are getting counterbalanced by these ones, right? But that's kind of a weird graph in general, which is why I like to put it in there. So I would count this as skewed left because these ones are so small, they're almost negligible. And there you go, you can see it. All right, so now that we know the basic shapes and we have them in our brain, we kind of want to look at some examples. So we want to identify the shapes of the distributions shown below if possible. And if not possible, we want to explain why. So let's look at this one. This has a large clump over here, and then it has a long tail, right? If you imagine the picture, has a long tail going off to the right. So this is very much skewed right. This is the first histogram we had in this section. And actually, so is this one. This one is also skewed right. Because they have tails to the right, right? If you're thinking of why. Right, for both of these. All right, now what about these two? These are from the previous section. And you'll notice the x-axis is words. So as a student, you might be inclined to say, oh, that's skewed right. Oh, no, it's not, right? Because these are words. The order here is arbitrary. You could put this in any order you like. This is actually a Pareto chart, right? So it was purposely built to go in this order. But there's no reason why it couldn't be reversed. You could put it in alphabetical order. You could put it in ascending order, right? Because they're words, they can be put into any order you want. Whereas over here, Numbers on a number line have an inherent order. 0 is to the left, 1, 2, 3, and 18 is over here to the right. It has an inherent order to the x-axis. But down here, it does not. That's why it said on the other page that you could only figure out the shapes for quantitative data, right? That's because qualitative data, the x-axis is arbitrary. Right, so that's why you cannot talk about the shapes of distributions for bar charts and Pareto charts, and pie charts for that matter too, but pie charts are circles, so they wouldn't have a shape anyway, right? But bar charts and pie charts and Pareto charts cannot have a shape. So bar charts and Pareto charts, right? Because this is a Pareto chart, that's a bar chart. Pareto charts have no shape. Right? They're not skewed left, they're not skewed right. Everything down here is completely arbitrary. You could reorganize it however you like, which is not the case in a quantitative variable.